Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel, everyone. Today we're going to be working on limit laws, and I'm going to be teaching you limit laws by doing problems. So rather than doing an introduction to limit laws and writing all of the limit laws and explaining each one of them, I am going to teach you, and we're going to work on problems, and we're going to walk through limit law questions that way, and then you're gonna get familiar with limit laws by doing problems. So that's my style for this video. Inshallah, my goal is to make another video where I go into detail on the introduction of limit laws and talking about each limit laws. But this time around, we're just gonna walk through them with mid to complex level problems. Okay, so the first thing you have to know is this. If you're given a question where the limit, we're taking the limit of, say, x, which is the variable, as x goes to a in this place is like a constant. It's important for you to know that that's going to be a. So you're taking the limit of x as x goes to a equals a. So for example, if you're supposed to take the limit of, say, x, where x goes to 2, right? The answer is going to be 2. So the answer is going to be whatever this is, right? Because all you're doing basically is substituting. You're finding the limit of x, but x goes to 2. So hence the answer is going to be 2. Just like you're looking for the limit of x, but x goes to a. So the limit of x as x goes to a is always going to give you a. So that's the first thing you have to do. But then what if you have a question, right, where you're taking the limit of a constant as x, which is the variable within like the entire limit, as x goes to a, right? Well, if you're taking the limit of a constant as x goes to a, what you're going to just end up getting is a constant, right? So that is how this works. In this particular case, x, in the first case right here, x is a variable, and we're taking the limit of the variable as it goes to a number a. In this particular case, the x is a variable, but then we're taking the limit of a constant, and the variable, we're not taking the limit of the variable, we're taking the limit of a constant. Even though we're doing it in such a way that the x goes to a number a, we're still gonna have the answer to be the constant. So let me give you an example so you guys don't get confused. So if you're supposed to take the limit of 5, whereas x, right, goes to 2, the answer is going to be 5. And this may be a little bit confusing, but honestly, this is really just what it is. Like the limit of a constant as the variable goes to a number or whatever is always going to give you that constant. And I think it's important for you to at least see this two limit laws first, and then with time you would kind of see what happens. So for example, if you're supposed to take the limit of pi, right, as x goes to, say, -7, you may be wondering, how do you work with this? Well, remember what pi is. Pi is a constant. So in this particular case, you don't have to overthink anything. Our answer is just going to be pi. We're doing more examples and more problems. You're going to see like what I'm talking about. So that is just like number 1, and then number 2, information to help you guys basically hopefully understand what is going on. When we do more problems, you're gonna see. So let's work on this example. Say you have the limit of 4x plus 2, right, as x goes to -3, right? The first thing you have to do is this. Whenever you're given a question that involves the limit of terms that are added together, in this case, the first term is 4x and the second term is 2. When you're given a question like this, you have to first of all multiply the limit through, basically. So what you're going to end up getting is going to be the limit, right, of 4x, right, as x goes to -3, plus the limit of 2 as x goes to -3. This particular rule where you're going to expand the bracket, basically expand the information or the function, involves you just doing the limits like addition and subtraction rule, where whenever you're given, so I'm going to show you what the general formula looks like first of all. So if you're given limit as x goes to a, right, of f of x plus g of x, the first thing you have to do is to do this. You're going to do a limit of f of x, right, as x goes to a, plus the limit of g of x as x goes to a. This is the answer. This is literally what it entails. This is what it entails whenever you're working with stuff like that. So this is another limit law. So this is the third limit law. We're going to be seeing a lot of these limit laws with time, and you're going to basically understand what is going on. This is the same thing with subtraction, right? If you have the limit law of limit as x goes to a, and then enclosed in a bracket is f of x minus g of x. That's the same thing as the limit as x goes to a, right, of f of x minus the limit of g of x as x goes to a. That's how it is. That's basically what it is. So that is two extra laws for you guys. So now that I've introduced 4 laws with you, I am going to take this question that we had and I'm going to do it on the next page. I'm just going to rewrite what we had here, what I'm like doing in a squiggly box. So our question was the limit of 4x plus 2 as x goes to -3. We got that to be limit, so we're going to expand of 4x, right, as x goes to -3 plus the limit of as x goes to 2, sorry, as x goes to -3, because we're expanding, of 2. So I don't want to confuse anybody, but I'm sure you guys will be like, well, why is she saying limit as x goes to -3 of 4x, and why is she now saying limit of 2 as x goes to -3? From what I understand, both is fine. You can say the limit as x goes to -3 of 4x, or you can say the limit of 2 as x goes to -3. So both are correct. Hopefully it doesn't confuse you guys. I just wanted to mention that so that it's easier. So now the next thing you do is this. The way we work with limits is to when we have this question, when we have this one right here, you can be wondering, like, how do you work with this, right? All you have to do, since it's limits and 4 is multiplied by x, right, 4x, you can bring out the 4 and then have this 4 as limit goes to x to -3 of x plus limit of 2 as x goes to -3. So therefore 4 multiplied by the limit of x as x goes to -3. What is that? Well, this is it right here. The limit of x as x goes to a is just a. So therefore, if you want to compare the first law similar to what you're looking at right here, then you're going to see that what you have here, 4 multiplied by the limit of x at x goes to -3 is the same thing as just having -3 right here, because we just substituted this entire information, and this entire information is equal to -3. By the way, whenever we're given the function and we're given the x, the input we have, which is x going to -3, we always want our outputs to be like a constant number, just so you guys know. So every single problem we're going to have actual answers. Like the answer could be a fraction, the answer could be a decimal, yeah, the answer could be a whole number, but we don't want our answers in terms of variables. The function can be in terms of variables, but the answer is always going to be in terms of a constant. So hence, x going to -3 is the x the x-axis, and our answer is always going to be towards the y-axis, and it's always going to be a constant. I just wanted you guys to know that. So, and you're going to see that as we do more problems. So 4 times negative 3, right, plus, what is the limit of 2 as x goes to negative 3? If you look at the previous page, what did I say? A limit of a constant as the variable, in this case x, goes to a particular number, right? It's always going to give you the constant. So even though we have an x going to a here, we're gonna ignore it. We're not going to take it into consideration when we want to get what our y-axis or answer is. So the answer is just simply 2. So it's going to be limit of 2, right, as x goes to negative 3. 2 is just by itself. It's a constant, doesn't have a variable or anything. We're just going to put 2 as the answer right here. So 4 times negative 3 is negative 12 plus 2. So our final answer is going to be negative 10. So therefore the limit as x goes to negative 3 of 4x plus 2 is equals to negative 10. That's basically the answer. That's literally is our answer. So I just wanted you guys to know that's the first problem. Now we're going to go to a problem that is a little bit more complicated, but it's not like impossible to work with. So that's that. Now we're going to go to a more advanced problem. This first part was just hopefully a really good introduction. So say you're given a question where you have the limit as x goes to 3 of this function 6x cubed minus 4x squared plus 2x minus 10. You have all of this, right? The first thing you have to do, remember, I told you guys, is whenever you have like a function enclosed in a bracket, you're just going to expand. So this is the same thing as saying I'm taking the limit, right? I'm going to take the limit as x goes to 3 of 6x cubed minus the limit, or as x goes to 3, right, of 4x squared plus the limit as x goes to 3 of 2x minus the limit as x goes to 3 of 10. So that's how you actually do it. And that's it. Basically, we expanded. That is the sum and the difference law. We actually did not just use one law. We expanded and then we used the sum and the difference law right here. Right? We just basically expanded through it and while applying this law and this law. So the sum law is this one because it's a positive sign, and the difference law is this one right here at the bottom, number 4, because it has a negative sign in between the two terms, and we combine both because it's different, because this function has both a negative sign and a positive sign, and of course another negative sign. So we just have to combine them. But anyways, that's the first thing. So what's the first thing I told you guys? Like, now we have to do each one of these limits individually, and then we're going to then apply the signs in between them. So we have to find the limit of each particular subterm, if you guys understand what I'm saying, or each particular subfunction before we add them up or subtract them in order for us to get the answer. So yeah. So the first thing you have to do here is we have the limit of 6x cubed. We are going to bring out 6, and then we're going to do the limit as x goes to 3 of whatever is left, and what we have left is x cubed, right? Minus, we're going to bring out 4, right? And then we're going to take the limit as x goes to 3 of x squared, okay, plus we're going to do 2 and bring out the limit of x, right? So we're bringing out 2. By the way, I'm going to use a red marker to show what was brought out. So we brought out 6 here, we brought out 4 here, we brought out 2 here. So we can just focus on the variables because we've brought out the constants in front of it. So, we brought out the reciprocals of the variables, and then we're just going to be focusing on the variables itself because it's easier for us to solve it that way. But with time, like if you're very good with math, you can skip like that step and just do a direct substitution. But we're building up in this video, so with time, you'll be able to kind of skip steps. But you have to be careful whenever you have like a more complex function not to skip too many steps, because then you can actually make a mistake and get the wrong answer. So you have minus limit of 10, right? As x goes to 3. Remember what I said about and getting whenever you have the limit of a constant, right? As the variable, in this case x, goes to a number which is 3. Well, we don't have any problem because we're taking the limit of a constant just like we saw right here, right? Right? That's what we're doing for the second law. For number 2 law, where the limit of a constant as a variable goes to a number is always going to give you a constant. So hence, we're going to have a negative 10. That is it. So yeah, that is just basically what you're going to have. And then you can start applying the limit as x goes to 3. So you have equals to 6 multiplied by, so you have x cubed, right, as x goes to 3. So they're going to have 3 raised to the power 3, right, because we're going to substitute 3 in where there is x. That's what we're planning. That's what we're going to be doing. So we have that down. So you have this here, and then you have 4, and then you have put in the 3. So that would be 3 squared, because we're substituting x for 3. Then we have plus 2, and we're substituting x for 3, so it will be 2 times 3 minus 10. So that would be 6. What is 3 times 3? 9. 9 times 3 is 27. So you have 27 right here, minus 4. 3 squared is 9. So you have 9 here, plus 2 times 3 is 6, minus 10. So 6 times 27, using your calculator, or if you're very good with a lot of this mental addition, subtraction, multiplication, you get the answer to be 162, minus 4 times 9 is 36, minus 36 plus 6 minus 10. So eventually you're going to get your answer to be 122. 122 is the answer. So this is the answer. This entire function that we had up top right here as limit for the limit. So the limit of this entire function, I apologize, as x goes to 3 is going to give you 122. As you can see, our answer is a constant, just like we have our answer here to be another constant, 122. The previous question 2 had a negative 10 as the answer, so that's a constant. So just so you know, we always try to get our answers to be, we don't always try, actually the answer is going to be a constant. So it can be a fraction constant, it can be a decimal constant, or it can be a whole number constant, but it's always going to give you a constant. So that's it. That's basically the answer. One thing I wanted to mention though is this. We first of all, when we break down the limits, to get subfunction limits, you can see that we had to get what all of this, each individual answer was calculated to be before we were allowed to apply the negative or minus, and we're allowed to apply the positive. So just so you know, we're gonna get what the answer is for the sublimits, and then we can either say, oh, it was added, it was subtracted, it was this, it was that, just so you guys know. Now, because we've already done a problem like this, I'm going to show you one law of limits, just to talk on it a little bit more, and then we can go to more problems. So you have a limit, right, as x goes to 2 of x raised to power n equals a raised to power n. This is a limit law. Actually, not x goes to 2. Sorry, x goes to a. So here it's supposed to be a. So let me just erase it and write it again. So x goes to a. So limit of x limit as x goes to a of x raised to the power of n is equals to a raised to the power n. What that is telling you is just like we had the limit of x as x goes to a to be a, anytime that variable that you have x has a power, in this case the power is n. So our power in this particular case, right, is n. We're still going to put whatever the input is supposed to be. In this case, the input of x, right, is gonna be a. We're still gonna put that. So this time around, the a is gonna be substituted, but also raised to the power. So that is how it works. So you have the power n in a red circle, you have a in a blue circle, and then you just have x, right? So therefore, because you're doing a limit as x, limit of function that has x, right? But then your limit is from x going to a particular number. Even though you're gonna put the number here, if that function that you initially had has a variable, has a power, you're going to still honor that power by putting it as the input raised to the power. I hope I did not confuse anybody, but that's how it works. And the way I can confirm this is the problem I did right here. I substituted 3 in all of this. So please look at the line, the third line. So the one with the blue arrow, so pointing towards the right direction, right? You see, there's the x. I substituted. So it's gonna take over the power as well. That is basically what happened here, and that is what I'm trying to explain here. So this is another law, and we're going to take this as the fifth law that we've already talked about. So this is the fifth law. Yeah, that's basically it. So now we're going to do another problem that is gonna like basically be of more, hopefully more value for you guys to understand some of the things that I have talked about today, and inshallah it will be something easy. So how about we do another problem that is complicated like this one too, right? It really makes sense for us to do that since we're already working on it anyway. So I'm going to give you another problem that is quite complicated like the previous one that we did. And please, if you would like to pause the video, it will be good for you actually to be able to just pause the video and work. Yeah, so that's that. So now, say we're given a question, finding the limit as x goes to -3 of 4x to the 4th minus 3x squared plus 5x plus 60. So how do you do this? Well, if you've been listening all through and if you've been writing down, you know the first thing we're going to do is that we're going to expand. So we're going to first of all expand, and we're going to have the limit, right, as x goes to -3, okay, of 4x to the 4th minus the limit as x goes to -3 of 3x squared plus the limit as x goes to -3 of 5x plus the limit at x goes to -3 of 60. So yeah, this is it. This is basically it. And the next thing you have to do is what I just explained. Well, not just what I just explained. What I explained previously is that we're going to bring out the constant. That's just what it is. To make our life easier so we can just focus basically on the variable. So we're going to bring our constant. We put a 4 here. Okay. Limit as x goes to -3, right, of x to the 4th, right, the 4 that was right here before has been brought forward. So there's that minus 3 of the limit of x squared as x goes to negative 3 plus 5 multiplied by the limit as x goes to negative 3 of x plus, now we have this question again where we have the limit of a constant. In this case, the constant is 60 as the variable x goes to a particular number, and in this case the particular number is negative 3. Well, just like I have explained previously, we're just going to put whatever the constant is because 60 is just by itself. We don't have any variable to work with 60, so we just get 60 because 60 is a constant by itself. So whatever it is going to be plus 60, right? That's how you apply it. So now applying the fifth limit law that we've talked about, which is the limit of x, which is a variable, as the variable x goes to n. The limit of x raised to the power of n as x goes to a is the same thing as the input, which is a raised to the power of the power. In this case it's n, but we're gonna still apply that here. And in this case we have 4, right? In open bracket we have x, and we're just going to substitute for each one of them. That's how you solve it. So then you have negative 3 raised to the power of 4, right? Minus 3, negative 3 all squared plus 5 multiplied by negative 3 plus 60. So what you end up with is equal to 4 multiplied by negative 3 raised to the power of 4 is the same thing as what, you guys? Well, negative 3 raised to the power of 4, the same thing as saying negative 3 raised to the power of 4 is just 81. The same thing as saying negative, well, we have negative, so it's going to be a positive, but 3 times 3 is 9, multiplied by another 3 times 3, which is 9. So 9 times 9 is 81. So you have 81 here. So 4 multiplied by 81 minus 3. Negative 3 squared is the same thing as 9. So that's that, plus 5 times negative 3 is negative 15. So we instead have negative 15 plus 60. So therefore we end up with 324 minus 27 minus 15 plus 60, and then what you end up with is going to be equals to 342, and that's going to be our answer. As you can see, the answer is, like I said, the input is always the x-axis and the output is always the y-axis. So this answer, if you put it on a graph, is always going to be in the y-axis, and it's always going to be a constant, and in this case the constant answer is basically 342. So that's it. That's basically it. Now I am going to teach you. We've talked about the sum and the difference law, we've talked about the polynomials and all of that stuff. It's now time for us to basically talk about other stuff, right? And I'm going to now teach you this next one. This is another limit law, which is the limit as x goes to a for n raised to the power of f of x, okay, equals to n of the limit as x goes to a. So do you know what this is telling you? This is telling you that the limit of a function, right, is the same thing as, the limit of a function that is enclosed in a square root, right, is going to be the square root of the limit of that function. That's basically what this is saying. So, for example, or I can even write it this way for those of you who would want things looking a little bit differently. So the limit of x of a, right, of f of x, and f of x is raised to the power of 1 over n, which is basically the square root, which is basically a root. So it could be a square root. If it's a square root, then it's going to be raised to the power of 1 over 2. If it's a cube root, it's going to be raised to the power of 1 over 3. If it is the fourth root, it's going to be raised to the power of 1 over 4. If it's the fifth root, it's going to be raised to the power of 1 over 5. So equals to you just getting the limit, okay, as x goes to a of f of x, right, all of that into closed brackets raised to the power of 1 over n. And that's basically it. So now I'm going to do the same thing here. I'm going to have the limit of the variable u in this case, so we're not using x here. And you're going to have u raised to the power of 4 plus 8u plus 16 raised to the power of 1 over 2. Or the question, basically, they give you a question looking like this, of u raised to the power negative 2, right? Square root u to the 4 plus 8u plus 16. Well, this is it. This is basically, the question can look like this here, or it can look like this. It can look like this. It can look like this. It can look like anything. So this is basically the question that we're going to attempt to solve. And the first thing you have to do is, since they've given us this problem, I'm going to actually work on it as it's raised to the power of 1 over 2. I think it's just easier that way. And that's it. That's how I'm going to work with it. So, limit of u is going to negative 2 of u raised to the power of 4 plus 8u plus 16 raised to the power of 1 over 2 is the same thing as limit of u going to negative 2, okay, of u to the 4th plus 8u plus 16, all of that information raised to the power of 1 half. So that's the first thing you have to do when you're trying to solve this. And then this is equal to this. So now that you have this limit of this function, it is important for you to know that we're going to put like a bracket to separate the function from the limit. I think you guys know where I'm going. So basically what I'm trying to say is this. You're going to end up with this, where you'd have limit of u going to negative 2 of u to the 4th, okay, plus plus the limit of u going to negative 2 of 8u, okay, plus the limit of u going to negative 2 of 16. All of that information raised to the power of half. So that's basically your answer. From this step that I just did, you can get your answer straight up. Honestly, if you wanted to solve it by yourself going forward, I advise you to just pause the video and attempt it. Or if you just want me to work on it and for us to finish it up together, that's no problem at all. So if you want to pause it now. If you don't want to, go on with me to the next slide. So now I'm going to just rewrite what we had from the previous page just for consistency purposes. And what we have is basically just rewriting limit of u going to negative 2 of u to the 4th plus limit of 8u as u goes to negative 2, okay, and plus limit of 16 as u goes to -2. All of this information raised to the power of 1/2, because remember we're dealing with like a question that has 1/2. So I'm just rewriting from the previous page. I'm sure from here, obviously, you know what's going to happen. So we're going to treat this information here like we have treated the last like 3-4 problems we've done since the beginning of the video. So what's going to happen is the limit of u to the 4th plus blah, blah, blah is going to be this. So what I'm going to do is I'm going to substitute u to -2, just like here. Put -2 in place of u, just right here, and that's what has to be done. So you have to do limit, so the bracket, limit, sorry, not limits, because we're substituting now. It's my bad. So we have to do -2 raised to the power of 4 plus 8, right? Where you have 8u, you're going to put a -2 in place of u. So -2 plus, now we have limit of 16 as u goes to -2. So limit of 16, because 16 is a constant and 16 is not multiplied by any variable, we're just going to put a plus 16 here, because like I had explained earlier, if you're taking the limit of a constant as the variable that you have or that you're given goes to a particular number, in this case there is no way to substitute there's no way to substitute u to -2 in this particular sublimit, because it's just the limit of a constant. So you're just going to have 16. All of that info, of course, raised to the power of 1/2. And therefore, what you end up with, it would be -2 -2 raised to the power of 4, which is just basically 16, plus 8 times -2 is the same thing as -16, so no more plus again. I'm just going to put -16 and then plus 16, because this just comes down, so plus 16. All of that information raised to the power of 1/2. 16 minus 16 is 0. 0 plus 16 is 16. So we end up with 16 here raised to the power of 1/2. 16 raised to the power of 1/2 is the same thing as square root of 16, which is the same thing as 4. So therefore, the limit as u goes to -15 of this u to the 4th plus 8u, which is our initial function, plus 16, that answer is the same thing as equal to 4. That is it. Honestly, that is basically it. I just wanted you guys to see something different. Of course, if you do more problems, you're going to be able to observe more. So that's that. Now we're going to move on to a more advanced question. It is not something that we cannot do, we can do it. And the more advanced question is going to open your eyes to a different limit law, and my goal is to teach you guys the limit law whenever you have a function that is a product. So yay, that's what we're going to be doing. So the next question we have is this. We're going to be solving this limit as x goes to -1, right, of x to the 5th minus 17x cubed, right, multiplied by 3x squared plus 6x plus 1. That is basically our function. Our function is x to the 5th minus 17x cubed in brackets multiplied by, in brackets, 3x squared plus 6x plus 1. That's basically our question. So the first thing we have to do is for us to get familiar with the product rule question. So whenever you have a limit, because the function we have is this entire thing multiplied by together, right? We can just put in a larger bracket so we can be able to differentiate the limit as x goes to -1 to the entire function that we're dealing with. We don't want a situation where we get confused or we do not solve it properly because we're not taking into account how the function is set up, basically. So this is the product rule. I'm going to teach you now the product rule for limits. And if you've seen what we've been doing so far, we first of all talked about limit laws when you're dealing with constants. We talked about limit law when you're dealing with immediate variable, when you're dealing with power of variables, when you're adding and subtracting functions together, sub-functions together to get a main function, and how you handle them basically as a polynomial function and how you do that. We already talked about how you have a polynomial function enclosed in a root, right? Enclosed in a root. That's what we've been doing so far. Now we're going to be doing two polynomial functions multiplied, or two sub-polynomial functions multiplied by each other to get an actual full function. So basically, this is what I said at the beginning of the video. We're building up the material. So we have product rule here. And yes, we have product rule here. You have the limit as x goes to a, right? And you have the product of f of x, right, multiplied by g of x equal to the limit as x goes to a of f of x multiplied by limit as x goes to a of g of x. So that's basically what you have to do. Find the limit of each of the sub-function and just multiply them together. So we're going to first of all work with one of them. I think that's wise. That's my plan actually. And then I'll work with the other one just so we can break things down. And then we can basically work from there. So I'm going to first of all isolate the first one. I'm going to apply what we just talked about to our actual question. So we have the limit as x goes to -1 of x to the 5th minus 17x cubed, okay, multiplied by the limit as x goes to -1 of 3x squared plus 6x plus 1. That is it. That's how you have to do it. What you have to now do is, since you're multiplying both, you're going to do this here, which is limit as x goes to -1 of x to the 5th minus 17, bring that out, of multiplied by the limit as x goes to -1 of x cubed, right, multiplied by the limit, right. Let's bring out the 3 because we've been doing this enough times to know we can bring out the 3. So we have 3 right here of the limit as x goes to -1, right, of x squared plus bring out 6 of the limit as of x as x goes to -1 as well, right, plus the limit as x goes to -1 of 1. That is it. This is quite interesting, honestly. So this is it. This is basically our work. So one thing we can do is just work on each one of them, isolate each one of them, and so that's that multiplied by this. That's what our plan and our goal is. So limit of limit of x to the 5th as x goes to -1 is basically just saying that we're going to substitute x going to -1 into here. So we're just going to have -1 raised to the power of 5 minus 17 which is this one. Remember what I did, right? We had 17x cubed, just like I had shown you guys before. You can always bring that the constant in front and then take the limits of the variable. So that's what I did right here, right? Don't be confused. That's what I did right here as well when I brought out 3. That's what I did right here when I brought out 6. So it's basically what we've done. Let me just show you from previous. That's what I did right here when I brought out 8 in the next. That's what I did. What was done here as well, and everything in red. So that's the same basically that's the same thing I'm doing here. I'm just using like a blue or red marker to underline it so you guys know what is going on. Hopefully this does not confuse you. If it confuses you, take a step back, take like a 2 minutes break or 5 minutes break, however long you need, and then come back and look at it again. Then it's gonna make sense. And also don't forget, you're using this video to learn and work and practice. You also need to get familiar with other questions and practice them as well. So you have -1 raised to the power of 5 minus, now you have 17 and you have x to the -1, right? This one right here, we're going to substitute it to x cubed. So that will be -17 -1 to the power of 3. That's that. So you multiply that together. That's that. And yeah, multiplied by, you now have 3. And then you have x to the -1, that will be -1 all squared plus 6 multiplied by -1. And then you have limit of 1 as x goes to -1. What is 1? 1 is a constant, and we're asked to get the limit of a constant as the variable that we're given, the variable of interest, is going to a number. In this particular case, we don't really care about the variable given going to a particular number or approaching to a particular number, which is -1. We just care about what the constant is. So we're just going to put a +1 here. It's no concern of ours, because it really doesn't add any benefit whatsoever, honestly. So I'm just going to rewrite what we had at the bottom here. I'm going to rewrite it on the next page. So what we have now will be, so -1 raised to the power of 5 minus 17, right? Multiplied by -1 raised to the power of 5. Oh no, not 5. That's my bad. 3. That's why you need to be careful when we're writing your work, you guys. 3. So that would be 3, right? Yeah, multiplied by three times -1. Sorry, 3 times -1 raised to the power of 2, right? Plus 6 multiplied by -1, right? Plus 1. That's basically, and you guys, if I make any like mistakes while I'm teaching, you guys can always like tell me. It's not a big deal. Or write in the comment section so that other people can be corrected as well. Of course, I'm not gonna get it right all the time, and I may make mistakes and I didn't even realize it while recording the video. So you have -1 raised to the power of 5, which is the same thing as -1, thank God, minus 17. -1 raised to the power of 3 is just basically -1, so -1 here. So -1 times -17 is positive 17, so that'll be -1 plus 17. Yeah, that's basically it. That's what we do. Then all of that information multiplied by this one right here. multiplied by 3 times negative 1 squared. So negative 1 squared is just 1, so that will be 3 times 1. And then 6 times negative 1 is negative 6 plus 1 right here. So that will be 3 times 1 is basically 3. Minus 6 plus 1 is minus 5. So that will be minus 1 plus 17. That will be 16 times 3 times 3 minus 5 is minus 2. So 16 times negative 2 is the same thing as what? Negative 38. So basically all that we've been doing just gives us the answer, negative 38. I'm going to give you a short summary of what we just did. Whenever you're given a function that involves two sub-functions multiplied by each other, what you're going to do is apply the product rule of limit laws. The limit law product rule just involves taking the limit of each of the sub-function. In this case, one of the sub-function is f of x, and f of x in this case is the same thing as x raised to the power of 5 minus 17x cubed, right? You take the limit of the first sub-function, which is the f of x, which is what I just mentioned, x raised to the power 5 minus 17x cubed, multiplied by the limit of the second sub-function, which is g of x, which is just saying that multiplied by taking the limit of 3x squared plus 6x plus 1. So that's what we did. We separated the product by taking the limit of each one of the sub-function, and then when we found the limit of each one of the sub-functions, we multiplied them together. Just like what we did whenever we were doing in the previous few slides, what we were doing, we were taking the limits and then we were applying the sum and difference rule. Like, you take the limit first and then you do the subtraction when it is necessary. That is basically what this is teaching you. You can see all of this work that we did, and we applying the power rule. Applying the power rule for limit laws, applying taking out the constant, applying the sum and the difference rule. Everything we were applying, right? We're just applying all of that, and then at the end, what we just had to do is just multiply whatever our answers were, and we had a negative 38. Actually, not negative 38, negative 32, because 16 times 2 is not 38. That's 19 times 2. 16 times 2 is 32. So 16 times negative 2 is negative 32. So this is our answer. So all that we did, that was just basically what we're trying to get at. We're trying to get at the answer. And yeah, that's about it. Of course, I can give you guys more problems, but for now, that is it for product rule. That's how you apply all product rule questions. And yeah, and I think that looking at this, watching this video closely will help you, even whenever the questions may seem quite different and more complex than even the ones I've been giving you guys so far. So the next thing we're going to do is we're going to work on the question that involves something called the quotient rule. Ha ha ha. Right? With the product rule, now we're doing the quotient rule. So say we were given a question that we had to be taking the limit of x raised to the power of 2 of 2x squared minus 3x plus 1 over x cubed plus 4. So what we have to do first of all is understand, well, we've been working so far and we haven't seen a question like this. So therefore, what are we supposed to do? This thing here is actually the function, right? And the limit as x goes to 2 of this function. So the next thing you just have to do basically is think of what rule we have to apply to first of all break down this information so that we can solve it. But what we have to apply is something you would call, or we would all call, or no, it's not what we would all call, it's what it's actually called, which is just the quotient rule. So we have the quotient rule, Yay! Quotient rule. And quotient rule is the that's the quotient rule, which is just basically us finding the limit of the numerator and finding the finding the limit of the numerator and finding the limit of the denominator, and then dividing or applying the division property. So basically what I'm saying is that if you're given a limit as x goes to a of f of x, right, divided by g of x, and f of x divided by g of x is basically the function, applying the limit involves finding the limit of x of x as x goes to a, or as x approaches a, of f of x first of all, right, divided by the limit as x approaches a of g of x. That's what's going on. Honestly, that's really it. So when you have that information, that's the first thing you have to do, and from there you're gonna understand what you have to do as you go forward. So that is the quotient rule. Just like the product rule involves taking the limit of each one of the subfunctions, multiplying the answers to the limits together. The same way you take the limit of the two subfunctions and then you apply the division property. So in this case, applying the quotient rule, we're going to end up with the limit, right, as x goes to 2 of the numerator function, which is basically 3x squared minus 3x plus 1 divided by the limit as x goes to 2 of x cubed plus 4. So yeah, that's basically it. That's all going to be equals to this. So now when you expand the function, right, that's what basically you have to do. Just expand the function like what we've been doing previously. So you're going to have the limit of 2x squared, okay, as x goes to 2, minus limit as x goes to 2 of 3x plus the limit as x goes to 2 of 1. All of that divided by the limit as x goes to 2 of x cubed plus the limit as x goes to 2 of 4. That is how you break it down. And I'm sure now that I've broken it down, some of you actually can solve this problem. But if you can't, we're going to do it together. And if you can, I would advise that you pause the video right here and then you can start solving. Okay. So we're going to go to the next page, and I'm just going to rewrite what we just did because I just want to make sure everybody's on the same page. So limit as x goes to 2 of 2x squared minus limit of 3x as x goes to 2 plus limit as x goes to 2 of 1 divided by limit as x goes to 2 of x cubed plus the limit as x goes to 2 of 4. So that's that. The next thing we have to do would be to bring out the 2. First off, remember how I explained to you guys, whenever you have a constant multiplied by a variable or a variable, whether the variable has a power or doesn't have a power, but that variable has a reciprocal that is a constant, we can simply bring out the constant. In this case, the reciprocal of x squared is what you would call, hold on a second. Okay, I just realized I've been making a mistake so far. I'm so sorry. It is not reciprocal. I've said this like 5, 6, 7 times, and then I'm like, dang, this is not right. What I meant to say is coefficient. Reciprocal is an inverse of something. So if I say reciprocal of x is the same thing as 1 over x, what I meant is coefficient. Coefficient. So the coefficient of x squared in this case is 2. So we're going to bring out 2, right? Multiplied by the limit of x squared as x goes to 2. So in this case, we're going to do the same thing. What we've done previously, you're going to be bringing out the coefficient. Whenever you have a coefficient multiplied by, when you have a variable multiplied by a constant, the constant in this case is 3, which is the coefficient of x. So we're going to bring that out as well, just like we've done previously, multiplied by the limit of x as x goes to 2. So a limit of x, and then, yes, as x goes to 2, plus, what is the limit of this again? The limit of a constant whenever the variable, in this case x, goes to an input, in this case 2. Well, because it's a constant and we can't really do anything about that, whether it's 2 or it's not 2 doesn't really have any effect. We just know that there's no variable to input or substitute anything to, so we're still going to retain the answer to be a constant. So that will be plus 1 divided by the limit of x cubed. The limit of x cubed is basically substituting to wherever there's x cubed, so that will be 2 raised to the power of 3. So that's that, right? Plus limit of 4 as x goes to 2 is the same thing as just putting 4 right here, and yeah, that'll be equals to 2. So 2 multiplied by the limit of x as, the limit of x squared as x goes to 2 is just substituting 2 right here into x squared. So that would be 2 multiplied by 2 squared minus 3. Same thing here. 3 multiplied by 2 plus 1. So that would be 2 raised to the power of 3 is the same thing as 2 raised to the power of 3 plus 4, right? So therefore what we can have is 2 multiplied by 2 squared is what? 2 squared is 4. So that would be 2 times 4 minus 3 times 2 is 6 plus 1 divided by 2 to the third is the same thing as 8. 8 plus 4, this is just basic math at this point. As 4 is 8. 8 minus 6 is 2 plus 1. 8 plus 4 is 12. So therefore what we end up having is 3 over 12. And when we try to break it down to the smallest possible fraction, we end up having a 1 over 4. So basically this is the answer. This whole question right here that looked quite complicated, the answer is just what we have to be 1 over 4. So, which is what we solved on to the next page. So if you can remember what I said, if you're given a question that looks like something like this, you should always start with doing direct substitution. But the first thing you have to do before you can even do direct substitution, since you have two subfunctions and it looks like one subfunction divided by another subfunction, you have to first of all find the limit of the numerator. You can find the limit of the denominator, and then you divide the numerator by the denominator, which is basically what we've done. So you have to do that first, when you can split the limit and do for the first top part and the second bottom part, and you can do that. Everything else is basically what we've done so far. It'll be easy for you to basically handle and do the questions, and we've done all of that, and we got our answer to be 1 over 4. So that's that. Now we're going to do a whole bunch of division problems, and you're going to see different things, and I hope really by God's grace that it's going to be easy for you guys going forward. So yeah, so then we have limit What's going on? Limit, as x goes to -3 of x squared plus 4x plus 3 divided by x squared minus 9. Of course, since you've been watching from the beginning, you know that the actual function that we're taking the limit of is x squared plus 4x plus 3 divided by x squared minus 9. So therefore, we can put in a bracket so that when we begin solving, we're not going to be confused as to what to do. So the first thing you can do is do like what I had explained before with the quotient rule. Right, the quotient rule for limit laws. We're just going to apply the limits to the numerator subfunction here, and also apply the limit as x goes to -3 to the denominator subfunction. So when we do that, this is what it's supposed to look like. So we're supposed to just limit as x goes to -3 of x squared plus 4x plus 3 over the limit as x goes to -3 of x squared minus 9. So this is basically what we've done. We split them. Now we can start working to apply the limit. So since this is in bracket, what are we going to do? We're going to multiply through. So we're going to do the limit as x goes to -3, right, of x squared plus the limit as x goes to -3 of 4x plus the limit as x goes to -3 of 3. All of this divided by the limit as of x squared as x goes to -3 minus the limit of as x goes to -3, right, of 9. So this is what you're basically going to do. And when you do that, what you should expect is this right here. When you do that, you should limit of x squared as x goes to -3, right? When you do that, you're going to do basically what we've been doing so far, right? You're going to input this -3 and substitute into x squared. Do the same thing, input -3 and substitute into x right here. Do the same thing here, substitute into x squared. So what we end up having is -3 squared plus 4 multiplied by -3, right? Because of the 4 that is basically here, right? Plus 3. So it's 3 because of what I've explained so far. The limit of a constant as the variable of interest goes to a particular number is always just going to give you the limit of the constant. So divided by the limit, divided by open bracket -3 squared, because we substituted -3 in x squared, and then we have the same situation. 9 is a constant, and the limit of a constant as the variable of the function goes to a particular number is always going to just give you the constant. So we have this. So therefore what we end up with is -3 squared is -3 squared is 9. 4 times -3 is basically -12, and then plus 3 over -3 squared is 9. 9 minus 9 is 0. So 9 minus 12 is -3 plus 3, that's 0 divided by 0. So this is basically our answer when we do the direct substitution method. But 0 over 0, right, is undefined. So therefore we cannot just say, oh, we're done, this is what we got, is 0 over 0. No, you cannot. This is not how you handle calculus. What you have to do anytime you have a question like this is for you to see if there's a way for you to break down the function, the limit function that you're given. So like how we first of all broke this down by applying the quotient rule, we're not going to do that first actually. What we're going to do first is that we're going to try to break down the function. When we've broken down the function, we can now apply the limit. So we have to do is try to simplify. So what we have to do is simplify the function. Same thing as break down the function. And then apply the limit. So rather than applying the limit first and simplify at the same time, or sorry, apply the limit first and then solve by simplifying so we can get the answer. Instead, we're going to simplify the function and then we can apply the limit. So I'm just going to rewrite the question since we're going to try to solve it again, but first simplifying it. So what we have from the previous page is the limit as x goes to -3 of x squared plus 4x plus 3 over x squared minus 9. Before we begin, I need to mention something. Please don't ever feel like, oh my god, I don't know what to do whenever I have questions like this. Many times, if you're studying this for the first time, especially if you're seeing this for the first time, you may be wondering, why does this like seem super complicated, right? Why is this so complicated? Like, why do I have to do this? The truth is you have to get the 0 over 0 as undefined before you can go on to the next step. So when you reach those points, if you're ever solving a question and you end up with a 0 over 0, don't give up, don't be sad. Just know that you're gonna apply a different trick. So going forward, and the truth is you have to get the 0 over 0 before you understand you have to apply a different trick. Except if you really know math very well and you've done a couple of problems that look like this. So when you get to the exam, you already know, okay, this is probably going to be undefined if I do direct substitution. But what I understand from my limited knowledge, or from the knowledge I have, of course, so far, I don't know everything, is that you're going to have to do the direct substitution method first. When you get stuck with the 0 over 0 as undefined, then you can go ahead to break it. So sometimes you can even know it's going to be undefined, but you still have to show your work so that me or your teacher or anybody, your tutor, can understand your thought process for simplifying before you apply the limits, which is what we're going to do here. So the way we can simplify this is, well, since we have a polynomial like up top, we can try to do a factor and canceling method. So let's try a factor, which is basically what you do. You try to do that first and see if you can factor stuff out. So factor / cancel out method. So what we're going to do now is that we write the limit as x goes to -3, but then we're going to factor and simplify the function first. So we're just putting the limit out there. We're not really doing much of anything. So it's just going to be chilling. So x squared plus 4x plus 3. If you use the factorization method, we know that we need two numbers that when you add them together, you get the second term, right? So we need two numbers that when we add them together, we get the second term, which is 4x, but in this case, we're focusing just on 4. And we want to make sure that those two terms, when you multiply them together, you're going to get the third term, which is plus 3. So we need two numbers. When added together, we're going to get it to be plus 4. And when we want those same two numbers, when multiplied by each other, we're going to end up getting plus 3. So those two numbers, off the top of our head, I mean, if you're doing calculus right now, you're supposed to be good with your factorization method. Those two numbers can be, those two numbers will be plus 1 and plus 3. So therefore, plus 1 plus 3. So when you add plus 1 and plus 3 together, you have plus 4x. When you multiply plus 1 and plus 3 together, what would you get? We're going to get positive 3, which is what we have here. So we can just literally write it down. So we can have it to be color. So we have x squared plus x plus 3x plus 3, and then we're gonna factor what is at the bottom too. What is this, right? What do two like terms we have to multiply by each other to be able to get x squared plus 9, x squared plus 9, sorry, x squared minus 9. X squared minus 9 can simply be broken down into x plus 3, right? And x minus 3. Just like if you have like a squared minus b, you can basically do a squared minus b squared. It is basically a plus b, right? And a minus b. That's the same thing going on here. Same thing as in x squared minus 3 squared, which is x plus 3 and x minus 3. That's the same thing you do if you have like x squared minus 16, or x squared minus 4, or x squared minus 25, or x squared minus 114. That's it. Like, you're gonna break it down to the square root of whatever it is and put them in form of like x plus the square root of the term that you're given, and x minus the square root of the term you're given. And in this case, we have x plus 3 and x minus 3, so we put x plus 3 and x minus 3. So then we have the limit as x goes to negative 3 to be x squared, sorry, not x squared, to be x plus 1 plus 3x plus 1. Okay, all of that information divided by x plus 3, x minus 3. So all of that equals to the limit as x goes to negative 3. So now that we've done this, we're going to do the simple thing that we always do. We have on both sides, on both sides of the positive sign, we have x plus 1 and x plus 1, so we can factor out x plus 1. And what would have left is x plus 3, right? Over x plus 3, x minus 3. I think now you guys kind of get where I'm going with this. So we've done the factoring out part of our work, right? This is a factoring and cancelling out method. Now let's do the cancelling out part of the work. So we have x plus 3 here, x plus 3 here. So therefore we've simplified it, and what we get our work to end up becoming is going to be the limit as x goes to negative 3 of x plus 1 divided by x minus 3. So rather than taking the limit of this entire question, which is x squared plus 4x plus 3 divided by x squared minus 9, taking the limits of that as x goes to negative 3, instead we're going to just be taking the simplified version of that, which is x plus 1 divided x minus 3. That's it. That's literally what we're doing. So let me go on to the next page. So we have the limit, so we're going to solve it together as x goes to negative 3 of x plus 1 divided by x minus 3. So that's it. Then we can basically do what we've been doing. Since this is a division, we're going to apply the quotient rule. Now we get to apply the quotient rule. So we end up with the limit as x goes to negative 3 of the numerator, which is x plus 1, divided by the limit as x goes to negative 3 of the denominator, which is x minus 3. So what you end up with is this limit as x goes to, so we're going to expand as x goes to negative 3 of x, right, plus the limit as x goes to negative 3 of 1 divided by the limit as x goes to negative 3 of x minus the limit as x goes to negative 3 of 3. That's it. That's literally it. I'm going to just rewrite the x. So now that we've had all of this done, I'm just going to simply substitute. So this here. So what we do here, we're going to simply substitute. So this is just going to give us -3 plus, what is the limit of a constant as the variable of interest goes to a particular number? It's always going to give us a constant. So 1 divided by, we're just going to substitute into -3. So we're going to just substitute x for -3. So I'm just going to have -3 here minus, what is the constant? What is this function? Well, it's just going to be the constant because it's the limit of a constant as a variable goes to a particular number, and it doesn't really affect us. It doesn't really affect the constant, so we're just going to put -3 here. So you have -3 plus 1 is same thing as -2. -3 minus -3 is -6. So you can cancel out and simplify, you get 1/3. So therefore, the limit of x as it goes to -3 of x squared plus 4x plus 3 over x squared minus 9 equals 1/3. So this is basically the answer, and this is just for you to be able to try and work with it, inshallah. May Allah subhanahu wa ta'ala make it easy for everybody. Ameen ya Allah. So yeah, that is it. Now I'm gonna give you one last question before we end the video, and then I'm gonna give you a series of instructions to help you, because that's the whole point. The goal is to help you guys as much as possible. So yeah, this next question is, what is the limit as x goes to 4 when you have x minus 2 over x minus 4? Well, we've got a function which is the square root of x minus 2 divided by x minus 4. How do you do this? Well, we're just going to apply the quotient rule, because that's what we're supposed to do first, since we have a question that involves a fraction. So when we apply the quotient rule for limit laws, we end up with limit as x goes to 4 of x minus limit as x goes to 4 of 2, all of that divided by limit as x as x goes to 4 minus the limit of x as it goes to 4 of 4. So when you get that done, you have this right here. You can have this is what you have. So what do you do next? Well, what you're gonna do next is this. And if you guys can see, you guys saw that I basically expanded and separated the limits for the numerator and the denominator, and I expanded at the same time. So I skipped a step. I've been doing this long enough that I can skip a step. If you don't want to skip a step, please don't skip it a step. So my point is, like, I'm skipping steps because I'm doing long enough, and I think that as we've progressed during the video, you guys can kind of see steps that have been missed. So in case you did not really get what I did, this is this is the step that I skipped. So I'm going to quickly write the step that I skipped. So this is going to be like the first thing first, and then this is going to be like the second thing. So this is what I skipped. Limit as x goes to 4 of this x minus 2 divided by limit as x goes to 4 of x minus 4. Yay! That's what the step that I skipped. So yeah, hopefully everybody's on the same page now. The next thing you do is you start to substitute. So substitute x into here, substitute x into here. So what you end up with is the square root of 4 minus limit of a constant, which is 2, as variable, in this case x, approaches a number, input number, which is 4. But because we're dealing with the limit of a constant, we're just going to put 2 here because that's how you take the limit of a constant. Divided by limit of x. Limit of x as x goes to 4 is just simply as 4. And then the constant here is just 4, minus 4. So that would be 2 minus 2 divided by 4 minus 4, which is 0 over 0. This is an undefined limit, or the limit does not exist, but we can't really say that until we try different methods. So this is undefined. So now, for next thing you have to think about is like, how do I simplify this function further so that I can apply the limit, so that I can actually do my work? It is just similar to the previous one we did. The only thing is that this one, because the top part is a polynomial that we can potentially factor, and the denominator we can potentially factor, and we can get factor at the bottom and at the top where we can cancel both of them out. The factor and cancel method works fine. But in this particular case, there's no way around factoring something from the denominator and something from the numerator, so we can cancel and simplify. So hence, the factoring and cancel method cannot work here. So whenever you have questions that have this square root type questions like conjugates and all of that stuff, so square root type question, you're gonna apply multiplication of conjugates. Like, so your knowledge of conjugates that you've done back in high school will be very important for you here. And if you've not done it before, I'm gonna walk you through it by doing this problem. So what we have here is the limit as z goes to 4 of a z minus 2 divided by z minus 4. So therefore, the goal is to simplify, because we've already tried it before and we got a we got a 0 over 0. So what is the best way to do it? We're going to multiply the numerator and denominator of this function by the conjugate of this z minus 2. So applying conjugate of this method of multiplying denominator and numerator, you don't only do it whenever you're stuck with limit questions. You always do this whenever you have a question where there is a square root and it is difficult for you to simplify. So you're going to try the conjugate method by applying the conjugates, by multiplying the numerator and denominator of whatever function that you have by the conjugate of whatever subfunction has a square root. So that's what you're going to do. And you don't only do it for limits, you do it for like other mathematical questions too. I'm sure you guys know from high school, before you even studied limits, you were already doing questions like this, and this will arise as you progress on in calculus to apply this understanding of simplification of square roots or partly square root questions by using the conjugate method. So hopefully that will be helpful as we progress. So this is what it's now supposed to look like, right? So we're going to first of all simplify the limits. Sorry, we're going to simplify the function first before we can apply the limits. Sorry, first of all, I don't know why I put z here. It's supposed to be x. So that's a mistake. So that will be x here, and that will be x here, that will be x. So limit of x as goes to 4, and what we have here would be x minus 2 divided by x minus 4 multiplied by square root of x plus 2 divided by square root of x plus 2. So therefore we have the limit as x goes to 4. So now we're just going to multiply through, inshallah. That's what we're going to do. So we're going to do the for method, right? Multiplying the first terms of both sides of both sides, and then we multiply the outers, we multiply the inners, and then we multiply the last, and we're going to add them up. So therefore the first would be, let me actually write it out, because I don't know everyone, for whatever country you're from, you might do it different. So foil, FOIL, right, is first, outers, inners, and last, right? The first terms in this particular one for here is, what are they? Well, this is what they are. They are x and x here, so that's the first. So I'm just going to put it first here. So you have x here and x here multiplied by each other. Then you have the outers, so which is going to be this 2, what is outermost, which is this 2, so that will be this x and multiplied by 2, right? Multiplied by 2. And then you have the inners, what is innermost, so that's 2 first multiplied by, actually not just 2, negative 2 multiplied by the square root of x, and then the last, which is the last here, so this one here, and which is just 2 multiplied by 2, actually not 2, negative 2 multiplied by 2. Yay! That's it. So we're gonna do the whole thing right here. So the square root of x multiplied by the square root of x plus 2 multiplied by the square root of x minus 2 multiplied by the square root of x minus 2 times 2. So we're going to do the same thing for the denominator. We have just x minus 4, okay, multiplied by square root of x plus 2. So we're just multiplying it. We're not going to multiply through in this one, and you're going to see why in a second. So now that we've done this, we can go ahead and actually do the multiplication, right? So the limit as x goes to x goes to 4 is x times x, square root of x times square root of x, the same thing as saying x raised to the power of half multiplied by x raised to the power of half, which is just basically x raised to the power of half plus half, which is 1, so that would just be x. That's mental math for you. Plus 2 root x minus 2 root x, interesting, minus 4, yay, divided by x minus 4 multiplied by square root of x plus 2. So plus 2 root x minus 2 root x is the same thing as 0, so that will be the limit as x goes to 4, which is plus 2 root x minus 2 root x is 0, so that will be x minus 4 over x minus 4 multiplied by the square root of x plus 2, So what would you do from here? Yay, we're going to cancel, because the conjugates method can involve simplification of our function, and simplification of our function sometimes or most times involves calculation of things that can be factored. So in a way, the conjugate method also involves factorization and cancelling things out. Even though that's not, you're not going to first of all factor, you're first of all going to apply the conjugate first of all, you're going to apply multiplying the conjugate for the numerator and also for the denominator, and then that simplifies your work enough to be able to factor stuff out and cancel stuff out. So you guys can see the progression of how all this is happening. I think that it's important for you to learn it, to do this problem again by yourself on your own, and do problems that are similar to this question by yourself on your own, so that you can master what is required in order for you to do well in the class. So the limit as x goes to 4 would be 1 over the square root of x plus 2. Guess what now? Since we've simplified the function, what we're gonna do is that we're gonna apply the limit. Yay! So we're gonna limit of as x goes to 4 of 1 divided by the limit as x goes to 4 of the square root of x plus 2. So that will be the limit of 1 as x goes to 1. So limit of 1 is a constant, so we're just going to have 1 here. And then a limit of square root of x as x goes to 4 is it just involves us doing what we know how to do. We just substitute, right? So that would here would end up having the square root of 4 plus 2. So that would be 1 over 2 plus 2, which is going to be 1 over 4. So the limit as x goes to 4 of square root of x minus 2 divided by x minus 4. So that's going to be 1 over 4. So that's basically that. Let's try and make it easy. We've come to the end of, or almost the end of this video. Hopefully this video was helpful to you guys. The goal is for people to basically learn and to be able to handle much more difficult problems by themselves. And that's basically the plan of this. Hopefully you guys have a great exam. I know that's a weird thing to say, but still have a great exam where you can hopefully be successful in what you're trying to accomplish. And that's the plan, I hope. So I would let you guys know there's going to be a part 2 for this, which is just going to involve us doing more problems. It's nothing major. I think that if people have watched this video, you can definitely handle more complex examples. So what I'm going to do is that I'm going to leave you guys with a page full of problems you could attempt that are going to be present in the next video. So part 2 of this video will just involve more of a practice for students who have watched part 1 of this video. So you have the questions I'm going to give you would include limit as x goes to negative 3 of 6x minus 17. Okay, that's question 1. Then you have a question of the limit as x goes to 2 of 3x squared minus 5x plus 2, okay, divided by x to the 4th plus 6. So basically this is the function. And number 3, we have a question that is finding the limit of x as it goes to 4 for 2x raised to the power of 5 minus 18x squared plus 3 divided by 3x cubed minus 19. And then you have a question on what is the limit as x goes to, many questions have been x goes to negative 3. This is another question like that, of x goes to negative 3, right, of the square root of 2x plus 22 minus 4 divided by x plus 3. That's the fourth question. And then the fifth question is taking the limit 5x cubed minus 3x squared plus x minus 6 divided by nothing. Actually, that's just the question. This one here, divided by nothing, or you can say divided by 1, same thing, but then it goes to 3. So these are 5 of the more than 5 questions I'm going to answer. I'm going to do practice problems with more than 5 questions, but attempt these 5 problems and just work with me. Next video, part 2 of this video, is just going to be more practice of questions like this, questions that are more advanced, but I do believe from what I've taught you guys so far, you'll be able to handle this question pretty well. And I hope to see you in the part 2 of this video. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.